That's where we are in the universe. Sometimes we are compared to explorers, adventurers.
Often described as the oldest of the sciences, astronomy is nowadays one of the most modern and dynamic. With the coming arrival of a new generation of terrestrial telescopes, like giants emerging from the Earth, we will experience a veritable revolution of universal knowledge. And we will be able to begin to answer some of the fundamental questions that fascinate us all. Where do we come from? Are we alone in the universe?
Earth-like planets around other stars are not science fiction. They exist. There are many of them, probably in their tens of billions. The big question is, what is on these planets?
In the world's most important observatories in Chile, Hawaii, or the Canary Islands, a new generation of astronomers, engineers, and technicians is writing the next chapter in our knowledge of the universe. We go and meet these people of the stars to discover what makes their hearts beat, but also to understand how astronomy deciphers our past and shapes our future. It is in one of the driest places on the planet, in the middle of the Atacama Desert in Chile, that one of the most important projects of the decade has just begun. Here, in this inhospitable place, man will build the largest terrestrial telescope in the world. The ELT, the Extremely Large Telescope, is a giant machine worth more than €1 billion that will pierce the sky like never before. The European Southern Observatory, which brings together some 15 European countries, is the originator of this mammoth project. And it was Pascal Lapeyre, the French manager of this extraordinary project, who decided for the first time to open its doors to us.
Where did you see some wires?
When we were through the road.
Ah, okay.
Here we're building what will be the largest telescope in the world. Its primary mirror will be 39.5 meters long, and we are here at the edge of the dome foundation. And this dome will be 96 meters in diameter and 85 meters high.
To see far, you have to think big. This is the motto of astronomers. The ELT will therefore be the largest of all. Imagine, you could fit 2 Arc de Triomphes in this dome. With its 39-meter diameter primary mirror, the ELT should multiply by 5 all our knowledge of our universe. Its revolutionary optical design is based on a principal mirror composed of 798 hexagonal segments, the first of which was successfully cast in Mainz, not far from Frankfurt in Germany. A 5-mirror system with integrated atmospheric turbulence processing will provide images of exceptional quality, as if the telescope was operating from space. Installed on Cerro Amazones, a mountain at an altitude of 3,046 meters, the ELT is expected to make its first observations in 2024.
We needed a certain area to install the ELT, so we cut into the mountain at about 80 meters in height until we reached the size of a plateau large enough to install a telescope and all the related equipment. It's a construction site in extreme conditions. We're all working in the extreme.
It's a huge step for the scientists in what they can expect from such a new telescope. The sensitivity, the resolution, or the sharpness of the images, all of this bring a lot of the unexpected things which they did not even dream of today.
How the universe functions still holds many secrets. Black holes, the nature of the cosmos and the Big Bang, the ELT will tackle the greatest scientific challenges of our time, including the search for planets similar to the Earth, and those orbiting in the habitable zone of stars other than the Sun, an area where life could exist, one of the holy grails of modern astronomy.
So if we, for example, would discover oxygen, ozone, chlorophyll, exciting things, methane, in the atmosphere of this planet, it's very exciting, not only for scientists. I think everybody who hears about that gets excited about this idea that we could really observe another planet which contains signatures of life, for example.
While waiting for the commissioning of this extraordinary telescope, it is only a few kilometers from the ELT site that the European Southern Observatory operates the VLT, the Very Large Telescope. At an altitude of 2,500 meters on Cerro Paranal, this observatory with its 4 immense telescopes has the most powerful optical system in the world, designed to explore distant galaxies and the far reaches of the universe. It was the VLT that made it possible to discover the supermassive black hole at the center of our galaxy, and which also found some of the oldest stars in our universe. And more recently, it was this telescope that managed to take the first picture of an exoplanet, a planet outside our solar system.
The image that people sometimes have is of the astronomer in his tower with his eye to the lens. That's an image that is pretty, but it's an image that has completely vanished. These days, this work is a team effort.
Each year, about 2,000 applications are submitted to use the ESO telescopes, which would require 4 to 6 times more nights than is currently available. And at more than 50,000 euros per night of observation, the VLT must be operational every night. An incredible mechanism, which requires a lot of maintenance and supervision.
The complete daily checkup of this telescope takes about 30 minutes. When you arrive, it's really impressive, but now I'm used to it. I know it very well. I know all its noises. I know its behavior, the time it takes to open up. It's a toy, but an expensive one.
It's the rendezvous. It's something that's been going on since the beginning of Paranal. In the time I've been working here, it's always been the time when everyone gets together to come and see the sunset. It's a special, magical place. It's true that one of the pleasures for many of us is not only to come at sunset, but also to leave the telescopes for a little bit and come and see the sky outside, just with the naked eye, because it is a show that is unlike any other.
Less than a minute was enough for the sun to disappear below the horizon. Then began what scientists call the astronomical twilight. The first stars appear slowly, while the domes open one after the other. It is at this precise moment that the telescopes pass into the hands of the operators. In the VLT's control room, everyone is at their post for a long night of observation. It has now been more than 2 years since Frederick, a Swiss national, joined the permanent teams of the European Southern Observatory.
It's an extremely complex machine with many cogs, many things that must work together, that must work in harmony. It's kind of like a spaceship. Like a spaceship, yes. I've never been on a spaceship, so I'm not sure. But it's true that once in a while it strikes me. I'm 32 years old and I'm at the controls of an 8-meter telescope that's really at the forefront of modern astronomy. But then I have to keep working, so I forget. But it's true that once in a while it makes me really wonder.
A telescope with its mirror is only a light collector. It is the instruments that are connected to it which will allow, each in its own way, to measure the properties of this collected light. Some are simple imagers who take pictures of the sky in different wavelengths. Others, like MUSE, are highly sophisticated spectrographs that decompose the light emitted by the observed object to obtain its chemical composition.
16, 15, 15, 16. Ah.
15, oh, 16.
Ah, yeah, okay, so that's, yeah, that's very faint. Okay, good, good, good.
For my part, I would like to observe this part of the galaxy with MUSE. And when you process it with software, you can reproduce the image on the sky. So this is the field of view that MUSE sees on the sky. And here we see a part of the galaxy that we have observed. What I can do is choose other colors, other wavelengths. By choosing the color, I have physical information that is different. And that, in fact, is how we manage to do physics, astrophysics, not just astronomy, where we take images that are interesting, that are important. But here we do astrophysics. The instruments are now really complex, and to see only the raw images coming out of the telescope is impossible to interpret directly.
To transform images taken by a telescope into photographs for the general public, scientists must produce what is called a composite image, a superposition where the choice of colors is left free to the appreciation of each astronomer. However, a convention combines certain colors with certain chemical elements. Helium, nitrogen, and oxygen are represented more in blue or green, while hydrogen is often red.
And so each new generation of instruments allows us to open up a potential for discovery that is extremely wide and that allows us to either look further or look in more detail and therefore effectively learn more about our universe more precisely.
Of extrasolar planets and the detection of planets similar to our own is an important first step to understand life in the universe. There are many questions to which we do not know the answer. We do not know if life arises naturally, where it should appear, how it should appear. But the first step is to try to understand if our planet is common or not. And that's what we are trying to do now. It's something that is very profound to us as human beings, more than as astronomers.
Hunting for exoplanets is a real challenge because these extrasolar worlds are very difficult to detect. They hide in the shadows, made almost invisible by the crushing brightness of their star. Using several methods, astronomers have already managed to find no less than 4,000 of them out of a possible hundreds of billions. A good start, especially since the latest exoplanets discovered have revealed an unexpected diversity by their sizes, orbits, and positions. But the one that everyone dreams of discovering would be a cousin of the Earth, or even super-Earths, capable of sheltering life, capable of welcoming it, or even one day of being habitable by man. It must still be possible to reach them though, because for the moment, the nearest one is still located 4 light-years away, or 40,000 billion kilometers.
In astronomy, the scale of us versus the universe, of our own experience versus the universe, is overwhelming. It is something that is very hard for us to perceive still as astronomers, because we are human, because after a certain point we cannot have a different feeling of 1 billion versus 1 trillion of stars. But it's still very interesting because it can captivate our imagination, and that's where we are in the universe. Even this recklessness, when we talk about the distance of exoplanets and how completely inaccessible they are to us within our life, our answer is basically, we don't care, we try anyway. And there is this excitement, there is this drive that we want to go forward. Sometimes we are compared to explorers, adventurers.
A new day dawns on the Atacama Desert and its immense rocky expanses. An ochre and stony landscape that gives the impression of exploring another planet. Further north, clinging to the Andes mountain range, the ESO operates a second site dedicated to observing the universe. Located at an altitude of 5,200 meters on the Chajnantor Plateau, the site of the ALMA radio telescope is the most extreme astronomical installation of all. It's a very unique instrument, which collects data 24 hours a day, and has made possible numerous discoveries about our origins. Given the altitude, the operation and observation center is not located near the antennae, but 2,000 meters below them. Radio astronomy is another way of observing the sky, and allows you to see things that an optical telescope cannot see. ALMA can see in both millimeter and sub-millimeter wavelengths, waves that fall between infrared and radio waves.
You normally look around to see what's the universe made of. And then sometimes, the older you get, the more experience you get, sometimes you don't need the eyes to actually know that, okay, I'm grabbing a mouse, I'm grabbing a pen, right? You don't need to see a dog because you know that it's a dog barking. The same way the astronomers realize that sometimes you don't need the optical, you need something in the infrared to actually probe deeper in regions that are too embedded in dust. So normally I compare ALMA with our own audition. So if you want to compare with yourself, here they are, okay? You have 2 antennas, okay? It was a big jump from before and after ALMA started observing the sky. Yeah. Every week we have a result from ALMA that you go, wow, we can do that.
One of ALMA's capabilities is to detect chemical molecules in the vast clouds of gas and dust where stars and planets are born. Detecting them allows us to know when certain molecules have found the optimal conditions to meet, associate, and give birth to life. In ALMA, as in all the observatories of the world, astronomy is only the last link in a great chain of knowledge and understanding. For one person who observes, there are dozens of others working behind the scenes. Caroline, a young French engineer, is responsible with her team for part of the maintenance on the antennae of the ALMA radio telescope.
To get to the antenna, you have to have oxygen bottles. The conditions are really very difficult. We realize that very quickly when we arrive at altitude, and for safety reasons, it is necessary.
Ready? We're ready to go up? Do you have all your safety equipment with you?
Yeah, from the shoes.
Okay, good, good. We're ready.
ALMA is composed of a network of 66 giant antennae that can be positioned in different configurations to observe distinct parts of the sky. In its widest configuration, ALMA acts like one large telescope with a diameter of 16 kilometers. This is called an interferometer. New technologies had to be invented to build ALMA, such as the huge transporters which move the antennae according to the observation programs.
On the right?
ALMA is installed in one of the most extreme places on the planet. Yesterday we had a snowstorm, and today we have to check all the antennae, check that there is no snow that has entered the mechanism, because they rotate in this direction and like this, in order to follow galaxies or other astronomers' observations. We are in a really incredible environment with all the volcanoes, the plateau. You can see for hundreds of kilometers. It's incredible.
At the very top of the Andes Cordillera, on the Chajnantor Plateau, we feel a little like we're on the top of the world, still on Earth, but already closer to the stars. It is in another place on the planet, completely isolated in the middle of the Pacific, in Hawaii, that there is an observation site as important as those in Chile. The highest peak in the Pacific at 4,207 meters, the dormant volcano Mauna Kea hosts a collection of international telescopes at its summit. Here, there are many research programs, but some telescopes have chosen to focus their efforts on the issue of extraterrestrial life. Every morning, Yuko travels the Saddle Road, a road carved through the volcanoes. Coordinator of the Subaru telescope, the Japanese National Telescope, she is scheduled to meet today with a French team that is developing a new instrument dedicated to the search for life elsewhere.
So when I first came here as an astronomer, I was so amazed by the number of stars. I saw Milky Way galaxy clearly. I saw hundreds of stars, and every 5 minutes I saw shooting star. And it was just wonderful experience. I really felt the universe. Universe was so close to me. So I feel like Mauna Kea is the gateway to the universe. Japanese astronomers wanted to build world-class telescope. And Japan is so humid. Even though we have Mount Fuji is not a good place to observe stars because of high humidity. And that's why the Japanese astronomers came here to build Subaru telescope.
We have dreamed of it for a long time, but today scientists are convinced of it. We will soon discover signs of extraterrestrial life. From hypothetical, the existence of life elsewhere has become probable. The question is no longer whether we will find it, but when. And Olivier Guillon and his team would like to be among those who will participate in this great discovery.
Hello.
How are things going today?
Quite well. The main cameras are all running. The interferometer, Stephen is doing some final work, but it seems to be running. That's the detector for it. So it's fiber fed. So we have fibers going from the instrument under here to here.
Are you going to use this tomorrow?
Yeah.
Our long-term priority is the search for life in the universe, the search for habitable planets in the nearby sky. So in this area, there is always a need for new technologies. And we're really here at the forefront of these technologies. We work with several international groups that are developing new detectors, new cameras, new light handling techniques, which we integrate into the instrument. We're really in this perspective of searching for life, actually.
That's why he chose Arizona, right? Yeah. Because he doesn't want
If we open, what is your next target? If we open, what's the brightness of your target?
Brightness is 7 or 8 magnitude.
Okay.
ALMA.
Okay. If we open, then it will be fine because these are quite bright for our wavefront sensor. So.
At the Subaru telescope, observations are mostly conducted in tandem. Tonight, Japanese astronomers in search of planets that could harbor signs of life have prepared a whole list of potentially interesting targets. They will be able to see live images taken by the telescope. Olivier oversees the program, hoping one day to find the first forms of extraterrestrial life.
Earth-like planets around other stars are not science fiction. They exist, and there are many. We think that between 10 and 50% of the stars in the sky have a rocky terrestrial-type planet at the right distance from them to have a temperature like the one we have on Earth. The number of potentially habitable planets in our galaxy is probably in the order of a few tens of billions. The big question is, what is on these planets? Is it an atmosphere with oxygen, water? Is there liquid water? Is there life? It is very difficult to anticipate what we will see, because we are surprised. Nature has more imagination than many scientists. The search for life outside our solar system is a huge philosophical question, since it touches on our origins, our place in the universe. It also touches on aspects of religion. These are universal questions that human beings have been asking themselves for a very long time. And the discovery of other life forms will be something that will change science. With a little luck, maybe we'll get in touch with our neighbors.
To prepare the future of astronomy, the Hawaiian archipelago is also participating in the giant telescope race. At the top of Mauna Kea, after 40 years of loyal service, the CFHT, the French, Canadian and Hawaiian telescope, is being totally overhauled.
We are one of the oldest telescopes built in the 70s. It would be nice to have an instrument come in basically from the start again, which is what we'll be doing, and then be able on the ground floor to see how everything goes together, and yeah, we'll see what happens.
The MSE project, Mauna Kea Spectroscopic Explorer, will transform the current 3.60-meter optical telescope into a 10-meter telescope that will be entirely dedicated to analyzing the composition of light on about 10,000 objects in the sky. In the CFHT's design offices, the design of the future telescope is already well advanced, and one of the scientific coordinators of this ambitious project is the Frenchman Nicolas Flaget.
Hold your breath. This is what MSE will look like in the future. We'll just keep the building at the top. This whole part here is the same as the current part. All this exists now. What has changed is what's above, so the dome and what's inside, which is the telescope. That's the telescope in its current design. The big boxes on the side are spectrographs. You can see the main mirror. In 10 years, we know that there will be giants, the 30-meter, the 40-meter, the ELT, the GMT, the TMT, which will all be part of the astrophysical landscape. And we know that there will be a need for a telescope like MSE, which will take spectroscopic measurements, and only that. One of the great discoveries of recent decades has been dark matter, dark energy. We know it exists, but we don't know what it is. Most of the universe, we don't know what it's made of. We don't know where it comes from. So MSE will have the opportunity to force a little bit the models that define dark matter, just to know what energy and matter there is in the universe. To be able to constrain its models of dark matter and energy, that is one of the first aspects. The other aspect is closer to us. We're going to look at our galaxy, and we're going to look at all the stars. We're going to look at millions of stars to see where they come from, what their chemical composition is. And we'll be able to put them in a family and know that this star and this star were probably created in the same place at the same time, and these stars too, and these stars too. We're going to try to roughly reconstruct the history of the galaxy by looking at the stars, by looking at the children of the galaxy, by trying to find out where these children come from, how they travel through the galaxy, and by trying to go back in time. What is the history of the formation of these stars, and therefore of the formation of the galaxy? These are two of the major areas that MSE will explore.
Currently in the design phase and seeking funding, the MSE project should be completed in 2025. In the meantime, as every evening, Callie arrives to sit in front of the consoles of the current telescope. This young astrophysics graduate will pilot it once again for about 10 astronomers, who will retrieve the data the next morning. These observations will undoubtedly be part of the last ones of this 40-year-old telescope.
So currently I'm opening the dome and I'm watching it through the webcam so that we know that's a safe environment, so I can see that nothing's falling on the telescope to ensure the safety essentially of everything going on up there. Everything is completely under control. So far I see no problems as I'm watching this, so it looks like it should be okay tonight.
While observatories can be found all over the world, there are more famous places than others. Along with Chile and Hawaii, the Canary Islands archipelago is also one of those exceptional places to look at the sky. With high mountains and trade winds which keep the clouds below the summits, it's not surprising that we find here the largest European observation centre, located on 2 of the 7 islands of the archipelago. Facilities that have enabled the IAC, the Canary Islands Institute of Astrophysics, to remain at the forefront of world astronomy. Today, on Palma Island, 4 Cherenkov telescopes, each 23 meters in diameter, are being assembled as part of the CTA project. A global network of more than 100 telescopes in different parts of the world.
CTA is a very ambitious project. To give you an idea, 1,400 people are currently participating in 32 countries and on 5 continents. What we mainly observe on this type of telescope are the most energetic phenomena in the universe. This is the largest project ever done in this range of energy. When we talk about astrophysics of great magnitudes, we can no longer be satisfied with a small group of people with 4 telescopes. We need to do huge projects like this one.
Cherenkov telescopes make it possible to observe very high-energy gamma rays emitted during violent cosmic phenomena. Because it must be acknowledged, seen from Earth, space looks like a peaceful and wonderful place, but in reality, it is a very brutal universe. Stars explode, galaxies collide, black holes devour everything that passes by. The energy rays caused by these cataclysms collide with the Earth's atmosphere and break down into a series of particles called cascades. By studying this phenomenon, the Cherenkov telescope makes it possible to reconstruct this energy and to guess the direction from where it was emitted. A new way to understand the activity of our universe.
This is the last area of astrophysics to be opened, and it really only started to work in the 1980s. We are in a way the young science of astrophysics.
Just a few meters from the site, the Grand Tecan, the observatory's emblem, stands proudly. Because until the ELT and its 39-meter mirror are put into service, it now has the largest mirror in the world at 10.4 meters, which still makes it the largest optical telescope in the world. Head of Scientific Operations, Antonio, has developed a real passion for this telescope.
The size of the mirror determines the power of the telescope, how far we can see. A telescope by its nature is a time machine, in the sense that light comes from so far away that it takes a long time to arrive. And that's very special, because on a large telescope, the more capacity you have, the more you can see back. As astronomers, we have the opportunity to study the different phases of the universe because we see them. It is as if a historian landed in the center of Paris and took a picture of the Champs-Élysées. And by zooming in, he could see Napoleon. And then by zooming in more, he could see Joan of Arc. And then by zooming in again and again, he could see the first Celts living there, or the Gauls. That's the capacity of astronomy.
If the Grand Tecan can explore the confines of the cosmos, it also participates in research on our much closer universe. A thorough knowledge of our own solar system and our surroundings remains one of the fundamental researches of astronomy. Julia is an asteroid specialist. Objects that have much to teach us about the formation of our planetary system, but some of which could also become a threat to the Earth.
It is very important to study our own solar system. It's great to explore and try to know the whole universe, but you have to start with the closest thing you have, and above all because it gives us information. Where we come from, how the Earth was formed, how life appeared on Earth. And I believe that this is one of the most important questions that human beings can ask themselves. It's a laboratory that we have on hand. Asteroids are remnants of, say, formation blocks of the solar system. That's how the planets were formed. And they have remained there since the beginning of the formation of the solar system. They provide us with information on the temperature that prevailed, what materials existed when the planets were built. And in this sense, it is very interesting. We are currently studying very small asteroids, which are very numerous and very difficult to study, and which can be a real danger to the Earth. In this area, this is a very significant step forward. And each new object we study brings us exciting new information that opens up new questions that will need to be answered. We have a lot of work to do.
The sky of the Canary Islands is absolutely pure. Since 1992, a law has protected it from light contamination and regulates, in particular, the air routes over the archipelago. Nothing is allowed to interfere with the observation of the sky. The future of astronomy in the Canary Islands is also being prepared on another island, Tenerife, where not far from the majestic Teide volcano, there is the largest concentration of solar telescopes in the world. Here, only one star is studied, ours. Deciphering the sun and understanding it is one of the keys to our own existence. Without it, we would not be here. The Teide Observatory provides European physicists with the largest solar telescopes available today. Installations that make for a huge solar laboratory, of which Adrian is one of the latest recruits.
Here, we have been studying the sun since the 1970s, and the stars, too. You can get information about the sun in all kinds of ways, which is why this place is so special. For living beings, without the sun, we are nothing. We would not have life, and of course, we would not be here now. It is the only star in the universe that we can see in detail, like the little mark that is being born here. We can study its magnetic field, its interior, its surface, its atmosphere.
200 billion stars populate our galaxy, and the sun is only one of them. A gas ball more than 1 million kilometers in diameter, in perpetual activity, and whose atmosphere is a complex environment, home to impressive eruptions and very intense magnetic fields. By studying the solar activity associated with these phenomena, researchers want to anticipate its effects on our planet, but also to understand the general functioning of stars.
We discovered about 30 or 40 years ago that there was a primordial movement of the sun that seems to be moving closer and further away from us. It is like the beating of the heart or like a breath. It can be measured and repeated every 5 minutes, but in addition, in this movement, we have many other small movements, like small waves of the sea moving on the surface of the sun. We cannot say precisely why this is happening, because we do not yet know for sure. We understand these processes, we know that they occur, but we do not know yet exactly how. We do not only want to study how the universe is, but also how it impacts us.
The Sun still holds many mysteries, and it is in an attempt to break through them one after the other that the TED Observatory has also decided to come and play in the big league. All solar physicists are unanimous. If we want to better understand the fundamental processes of solar physics, it is necessary to build a new generation solar telescope with a large aperture. This project is called the EST, the European Solar Telescope.
Studying the Sun is important for various reasons. First, to simply better understand physics, the interactions between plasmas such as solar plasma with magnetic fields, and second, we would like to predict when the Sun could produce certain solar phenomena such as eruptions, which could have an impact on our new technologies. Ideally, these events should be anticipated in order to be prepared.
Solar magnetic activity causes changes on Earth that can affect our new technologies and therefore our daily lives. Being able to better understand the relationship between the flow of solar energy and the Earth's climate could also help to mitigate its effects more effectively. With unprecedented precision, the EST will rediscover our Sun and should allow us to continue to live with it in the best possible harmony.
The new EST is a telescope like no other, and it will really make a difference when it comes to observing the Sun.
Since man has been scanning the sky, there have never been so many projects to decipher the universe around us and to push the limits of our knowledge ever further. All over the world, a new generation of researchers at the controls of ever larger and more powerful telescopes is dreaming of finally unlocking the ultimate secrets of the universe. A scientific and philosophical quest that will continue to surprise us and with which we will have to expect the unexpected. Astronomy is a science in which reality very often exceeds fiction.
I think I'm really mostly looking forward to the things we will discover which we do not think about today, which we cannot even dream about. And these are, for me, are the most exciting because they trigger then also the next question, the next instrument, the next telescope. This is this never-ending. Let's see when we meet again in 20 years what we have discovered, and then we can have another good conversation.